the NEET and AIMS. Okay. So first of all, you pause the screen and write down all these questions. Three questions are there. Question number 1 is asked in AIMS 2019, and question number 2 is asked in AIMS 2011, and question number 3 is asked in AIMT 2009. Okay. So first of all, you write down all these questions. Okay. You pause the screen and write down all these questions. Then we'll solve them. Okay. So let's solve example number 1. So example number 1 is like this. I'll rub this off. So let's see what's example number 1. In example number 1, force is given as a function of time. There is a force which is exerted by a gun on the bullet and is given by this. Okay. Then the bullet emerges with a velocity of 400 meters per second. Then you will have to calculate the impulse, which is also change in momentum, exerted till the force on the bullet becomes equal to 0. Okay. Okay. अब ध्यान रखो यहाँ बेटा. So first of all, what we'll write down is this force. So force is given to me. So the solution is like this. Force is given to me, that is equal to 100 minus 0.5 into 10 raised to the power 5, or I can write like this. It is equal to 5 into 10 raised to the power 4 t Newton, isn't it? Because 0.5 is 5 into 10 raised to the power minus 1, so 10 raised to the power minus 1 and 10 raised to the power 5 will be equal to 10 raised to the power 4. Okay. Okay. So next, what I will do is this. I will calculate. Then you will have to calculate the impulse exerted till the force on the bullet becomes equal to 0. We'll substitute that the force is equal to 0. Suppose that force is equal to 0. This implies that this 100 minus 5 into 10 raised to the power 4 multiplied by t is equal to 0, which in turn implies that 100 is equal to 5 into 10 raised to the power 4 multiplied by t, isn't it? So this 10 raised to the power 2. So this will be here. I can write it like this. This here 10 multiplied by 10 raised to the power 1 multiplied by 10 raised to the power minus 4. This one divided by 5, what is equal to t. Okay. So this here 10 and 10 raised to the power 1. Then here it is 10 raised to the power minus 4, और यहाँ आ जाएगा 5. Okay. So 10 by 5 is equal to 2 multiplied by 10 raised to the power 1 minus 4, that is minus 3. So this is equal to t. Okay. So at this time the force will be equal to 0. Okay. Now how to calculate it? अब ऐसे कर लेते हैं बेटा. So impulse is simply equal to delta p, and that is equal to integration of f dt. Okay, we are already done with this. Okay, delta p is equal to integration of f dt, and that's in turn equal to impulse. Okay. Now, what I will write is this. We have to calculate impulse. So impulse will be equal to integration of force. अब force के बाद क्या substitute कर लेंगे? ये substitute कर लेंगे. So here I will write down 100 minus 5 into 10 raised to the power 4 multiplied by t with respect to t. Okay, and the limits of integration are from 0 to this time 2 into 10 raised to the power minus 3, isn't it? Okay, now integrate it. Okay, so impulse will be equal to, this will be simply 100 L side, it's a constant, multiplied by t, minus integration of this is 5 into 10 raised to the power 4 multiplied by t square divided by 2, because integration of x raised to the power n is x raised to the power n plus 1 divided by n plus 1, and the lower limit is 0 and the upper limit will be equal to 2 into 10 raised to the power minus 3. Okay, now lower limit becomes 0 because this is also equal to 0, this is also equal to 0, so the lower limit will vanish, but the upper limit will remain L side, so the impulse will be equal to. अब ध्यान रखो बेटा. So here I will write down 10 raised to the power 2 multiplied by this t. T के बदले क्या लिखेंगे? 2 into 10 raised to the power minus 3. Okay. Then here I will write down. So this 2 into 10 raised to the power minus 3. This 10 raised to the power 2. Okay. Minus this 5 by 2. That's 2.5. 2.5. Okay. Or I can write it like this. It is L side 5 divided by 2 multiplied by this here 10 raised to the power 4. Now this t square, so 2 square is 4 multiplied by 10 raised to the power minus 3, 4 square is 10 raised to the power minus 6. ठीक है ना बेटा? Okay. Now next it's like this. So impulse I, it will be equal to this here 2 into 10 raised to the power minus 1. 2 into 10 raised to the power minus 1 minus. This will be 2 ones are 2, 2 twos are 4, then 5 twos are 10. Then it's 10 into 10 raised to the power 4 is 10 raised to the power 5. 10 raised to the power 5 into 10 raised to the power minus 6 is 10 raised to the power minus 1. So simply this will become 10 raised to the power minus 1. Now 2 into 10 raised to the power minus 1 minus 1 times 10 raised to the power minus 1, it is simply equal to 10 raised to the power minus 1. So impulse is this. Or finally you can write down the answer here. That impulse is equal to 10 raised to the power minus 1 Newton second, or it is equal to 0.1 Newton second. वही है इसका आंसर. So this is the question which is asked in AIMS 2019. Okay. Again I will repeat. force is given as a function of time, and initial velocity of the bullet is given, that is equal to 400 meter per second. Okay, so now the question is calculate the impulse exerted till the force in the bullet becomes equal to 0. When the force becomes equal to 0, we will calculate that time. So that time is this 20 10 to the power minus 3. Okay, now impulse in turn equal to integration f dt. F is given to you, so put it here. So this 100 minus 5 into 10 to the power, this 5 into 10 to the power 4 t with respect to t. Okay, integration of this will be 100 into t minus, this is 5 air side, 10 to the power 4 air side, its integration will be t square divided by 2. Okay na beta? Now lower limit will vanish, that will be equal to 0, but upper limit will not be equal to 0. So impulse will be equal to this here 10 to the power 2, and this t is here 2 into 10 to the power minus 3 minus this 5 by 2 into 10 to the power 4, and this will be 2 square is 4 into 2 square is this 4, this here 10 is to the power 4, then 2 square will be equal to 4, that is 10 to the power minus 6. Then try to solve it, this will become 2 into 10 to the power minus 1 minus this here 2 ones are 2 2s are 4, 5 2s are 10. So this here 10 into 10 to the power 4 is 10 to the power 5, 10 to the power 5 into 10 to the power minus 6 will be 10 to the power minus 1. So 2 multiplied by 10 to the power minus 1 minus 1 times 10 to the power minus 1 will be 1 times 10 to the power minus 1, or that's simply equal to 0.1. Okay na beta? 10 to the power minus 1 implies 1 by 10, so 1 by 10 is also equal to 0.1 nanosecond. So this is the answer. So iska answer ye hai beta. So likho. So simply pause the screen and write it down. Pause the screen and write it down. Okay, now concentrate. Okay, now there's one more example, example number 2, and example number 2 has been asked in Amos 2011. Amos 2011, and the example is like this: that mass of a particle is given to you. Mass of particle is how much? That's equal to 0.2 kg. It is given to you. Okay, and is subjected, and force is given to you. That force is given, that's equal to 0.3 I kf minus 0.4 j kf. This is also given to you. Okay, and initial velocity is equal to 0. It is given to initial velocity is 0. Now the question is calculate the velocity for 6 seconds. So t is equal to 6 seconds. You will have to calculate what's the velocity of the particle. Okay, so simply we'll use the equation v is equal to u plus at. Initial velocity is given, that is equal to 0. Time is given to us, but the acceleration is not given to us. Acceleration I will calculate from the second law. Okay, so what is second law? Second law of motion is simply like this: f is equal to m multiplied by a. From here I can calculate what is the value of the a. A will be equal to f divided by m. Okay na beta? So f is how much? That's equal to 0.3 I kf minus 0.4 j kf divided by mass. How much is the mass of the particle? That is 0.2. So it will be 0.3 divided by 0.2 I kf minus 0.4 divided by 0.2 j kf. Or you can write it like this: this here 3 by 2 I kf minus this here 4 by 2, that's 2 j kf. So this is the value of the acceleration, isn't it? So यहाँ से हमने acceleration निकाला from the Newton's second law of motion. Okay, but we have to calculate the velocity of the particle at the end of 2 seconds. So let's use the equation of motion. Equation of motion is like this: v is equal to u plus at. Initial velocity given, that's equal to 0. So this is 0, and acceleration is we have calculated acceleration plus this is 3 by 2 multiplied by I kf minus 2 multiplied by j kf multiplied by the time. Time is given, that's equal to 6 seconds. So velocity v will be equal to 3 into 6 is 18 divided by 2 I kf, 6 to the 12, so minus 12 j kf. So velocity becomes equal to this here 9 I kf minus 12 j kf. So this is the question that is asked in Amos 2011. If you want to calculate its magnitude, you can calculate magnitude as well. V will be equal to under root of 9 square plus 12 square. Okay, then try to get some. ठीक है ना बेटा? Okay, this is the answer. So ये answer है इसका. Okay, so this question is asked in Amos 2011. Simply what is given to you is mass and force is given. Initial velocity, the particle starts from the rest, implies that initial velocity is equal to 0. Now the question is calculate the velocity of the particle at the end of 6 seconds. So first of all I have used Newton's second law of motion. F is equal to m multiplied by a. यहाँ से मैं निकालूंगा पहले. So this is the acceleration. and then substitute in this equation. This is the equation of motion. Here this equation of motion. Equation of motion V is equal to u plus at. Initial velocity is 0. Acceleration we have calculated, and time is given to us. From here we can calculate what's the velocity at the end of 6 seconds. Okay. So again pause the screen and write it down. देखो बेटा यहाँ तक. Okay, so there's one more question that's asked in NLM 2009, and that's even simple question. One more question is there that's asked in AIPMT 2009. अब ध्यान रखो बेटा. Okay, the question is like this. Force is given to you. A force equal to 6 I kf minus 8 into j kf plus 10 multiplied by the k kf. Okay, force is given to you. It's in Newton. Force acting on a particle is given, and the acceleration of the particle is given, that is equal to 1 meter per second square. Now the question is calculate the mass of the particle. Mass of particle is equal to what? Easy question. Simply use the equation F is equal to m multiplied by a. From there you can calculate the mass. Okay. So simply F is equal to m multiplied by a. Solution. First of all, let's calculate the magnitude of the force. Magnitude of force F will be equal to under root of this here 6 square plus 8 square plus 10 square. ठीक है ना बेटा? So this is the way we calculate the magnitude of a vector. Okay. So F will be equal to 6 square कितना हुआ? 36, 8 square, 64 plus 10 square, that is equal to 100. Easy. Now 36 plus 64 is 100. So that will be equal to 2 multiplied by 100. Root of 100 is 10, so 10 under root 2 is the force Newton. So this is force. Then you want to calculate mass. Mass will be equal to force divided by acceleration. So force is 10 under root 2, acceleration is 1 kg. So mass is simply equal to 10 under root 2 kg. So it is answer. Okay, easy problem. Simply force is given, acceleration is given to us, and we are supposed to calculate the mass. So simple substitution. Okay, so force. From there we can calculate the mass. Easy problem. There is no rocket science in it. देखो बेटा यहाँ तक. So write it down. Okay, so we have done 3 examples that are asked in the Newton's second that are asked on Newton's second law of motion in NEET and EMS. Okay. Now write down graph problems. देखो बेटा graph problems that are based on the Newton's second law of motion. Graph problems. So here I will write down graph problems. Graph problems. देखो बेटा यहाँ graph problems. Okay. So I will repeat Newton's second law of motion again. All those equations. Equation number 1 is like this. So here I will write down NLM second Newton's second law of motion. Okay. Newton's second law of motion. Equation number 1 is this. That is force is equal to instantaneous force is equal to dp divided by dt, and that's in turn equal to tan theta, or that is slope. Okay, we have done example on this, but we have not done example on this. This implies that if you have p versus t curve, the slope of p versus t curve will give the force. Okay, so equation number second. Ab ध्यान रखो बेटा. Equation number first is this. Equation number second is like this. Delta t or impulse is equal to integration of f dt. And that's equal to area under the curve. Area under F versus T graph. Area under F versus T graph. Then number third is average force is equal to delta T divided by delta T. 1 divided by delta T. Delta T के बाद हम ये equation substitute कर देंगे, so integration of F dt. So that's equal to 1 by delta T, and this is in turn equal to area of F versus T curve. Okay, so multiply with the area under F versus T curve. Area under F versus T curve. Okay. So first of all, write down all these 3 equations. First use slope. Second area. First equation implies that the force is equal, instantaneous force is equal to slope of P versus T curve. Second equation implies that impulse or the change in momentum is equal to the area under force versus T curve. And third is this. Okay. And write down important point here. यहाँ लिखो बेटा important point. And that important point is like this. That area above time axis area above time axis. Area above time axis is taken positive, and area below time axis is taken as negative. Here, important sign convention. Area above time axis is taken as positive and area below time axis is taken as negative. Okay, तो यहाँ तक लिखो बेटा, हो गया. Simply pause screen and write it down quickly. देखो बेटा, अब ध्यान रखो. So first of all, let's plot P versus T curve and do the examples. Okay, let's do the examples on that. We have done side types examples already in the kinematics. Okay, so example number one. अब ध्यान रखो बेटा. Example number one. For example, P versus T curve is given to us. So like this it is. This is here P, and it is given in kilogram meter per second, and this here time T in seconds. And the graph is suppose like this. Suppose the graph is like this. ऐसे ग्राफ दिया गया है. Okay, so this here point O, this is A, this is B, and this is C. Okay, it is given that this here 20, we can apply this 20 kilogram meter per second is the moment. Okay, and then here it is given, this time is given, this time is given, and this time is also given. Okay, suppose it is given that this is 2 seconds, this is 4 seconds, and this is here 8 seconds. Okay, so this time in seconds, and this here point C. Okay, so first of all, it implies that from point O to point A, the momentum increases linearly with time. Then from A to B, the momentum remains constant at 20 kilogram meter per second. Then from point B to point C, momentum decreases. Okay ना बेटा? Okay. Okay, अब ध्यान रखो बेटा. Now calculate. What you have to calculate is this. So calculate A part. Calculate A part momentum P at time at t equal to 1 second, comma 3 seconds, comma 5 seconds. And these three different types you have to calculate the instantaneous momentum. Part B is like this. Part B is that calculate force. Calculate force at t equal to same time 1 second, 3 seconds, and 5 seconds. So you have to calculate these two parameters. Okay. So first of all, momentum and then force. Okay. So let's calculate the momentum at t equal to 1 second. Ab ध्यान रखो बेटा. Okay. So how to calculate momentum? ध्यान रखो बेटा. So A part is like this. We have to calculate the momentum at t equal to 1 second. At t equal to 1 second, we are supposed to calculate the momentum. We know that the momentum at 0 seconds is equal to 0, and momentum at 2 seconds is equal to 20, but we don't know what is the momentum at 1 second. Suppose this here 1 second, we'll draw a vertical line here, ठीक है ना बेटा? Then a horizontal line here. So this is the momentum we have to calculate. We have to calculate this momentum at 1 second. ठीक है ना बेटा? Okay. So suppose this angle here that's equal to theta. ठीक? Okay. So I will calculate here what is tan theta. I will calculate tan theta from the smaller triangle as well as from the larger triangle. From smaller triangle, छोटा सा triangle and बड़ा सा triangle. ठीक है ना बेटा? From smaller triangle, tan theta is equal to P, perpendicular is P, hypotenuse is 1, P divided by 1. And from larger triangle, it is equal to 20 divided by 2. So 20 divided by 2. From here we can calculate P. Okay, 20 by 2 is simply 10. 10 multiplied by 1 is 10. So momentum P is equal to 10 kilogram meter per second. That's for where? Here's the answer. So the momentum at t equal to 1 second is how much? 10 kilogram meter per second. Then add t equal to 2 seconds. At t equal to 3 seconds we have to calculate. At t equal to 3 seconds we have to calculate. Simply at t equal to 2 seconds the momentum is 20. And it remains constant between t equal to 2 seconds and t equal to 4 seconds. So the momentum obviously at t equal to 3 seconds will be 20. So simply we will write down here 20 kilogram meter per second, and as it is obvious from the graph. It's quite obvious from the graph. Then we have to calculate the momentum at t equal to what time? At 5 seconds. Okay, t equal to 5 seconds. Okay, now t equal to 5 seconds, so 5 seconds will be somewhere here. So again, suppose this is here momentum P. This is momentum P again. Suppose this angle here it is theta. Now what I will calculate is again tan theta. Tan theta will be what? Perpendicular divided by base. So in smaller triangle it will be perpendicular, that is P divided by this base. This is here 8 minus 3, that is 8 minus 5, that is equal to 3. This here 5 and this is 8, so 8 minus 5 will be equal to 3. So perpendicular divided by 3 is equal to, then this perpendicular, that is 20 divided by 8 minus 4 is 4. Okay, so from that equation we can calculate what's the momentum at t equal to 5 seconds. So here I will write down P divided by 3 will be equal to 20 by 4, that's equal to 5. So P is equal to 15, 5 3s are 15 kilogram meter per second. So A part. Okay, this is the way we calculate momentum, exactly in the exactly same fashion. We have repeated this problem. We have done this problem in the kinematics. Okay, and that is situation x versus t graph was given to you, and we have to calculate position at the different times. Okay, now B part. Ab dhyan rakho beta. B part is that you have to calculate the force. So for that I will write like this: force is equal to dp divided by dt, and that's in turn equal to slope, which is equal to tan theta. Okay na beta? Okay. So first of all, at what time we have to calculate? At t equal to 1 second. T equal to 1 second is here. We will calculate tan theta. Tan theta will be equal to perpendicular divided by base. So perpendicular here 20, base 2. So it will be 20 divided by 2, that is 10. So the answer will be 10 Newton, simple. Take next, at what time we have to calculate? So here I will write down at t equal to 3 seconds. We have to calculate force. At t equal to 3 seconds, we have to calculate force. Now, ab dhyan rakho beta. This horizontal line is AB. It makes an angle 0 degree with the horizontal because it is parallel to the horizontal. So यहाँ कितना है theta beta? 0 degree. When theta will be 0 degree, so tan theta is equal to 0, which implies that the force is equal to 0. Also, whenever the momentum remains constant or the velocity remains constant, the force of the particle is equal to 0 as per first law of motion. ठीक है ना बेटा? Okay. Now next is that what we have is this at time what? At t equal to 5 seconds. So again the force F will be equal to tan theta. It will be equal to tan theta. But here the slope will be negative because the momentum is decreasing. When the momentum is decreasing, force will be negative, and negative force implies retarding force. The force of retardation. ठीक है ना बेटा? So tan theta will be perpendicular, and this perpendicular is how much? That is 20. So here I will write down minus 20. Minus I submit क्यों? Because the slope is number one reason. The slope is negative, and number second reason is that the momentum is decreasing. When the momentum will decrease, the force will be negative. Okay, so this is here minus 20. Okay, divided by 8 minus 4 is 4. Divided by 4. So the force here, that will be equal to minus 5 Newton. So we are done with the problem with the part A as well as with the part B. Okay? ठीक? ठीक है ना बेटा? Okay, write it down. So simply pause the screen and write it down. We'll do one more example on this of this type. Let's do one more example of this P versus T. Suppose P versus T curve is given to you and you are supposed to calculate different parameters. We can do one more problem. Okay, so let's do another example on this. अब ध्यान रखो बेटा. Let's do one more example on this. Example number 2. So let's do example number 2. So again, momentum versus time graph is given to you. So suppose here we have this is momentum, and this is here time. Momentum versus time curve is given to you. Suppose the curve is like this. Simply it is like this. Okay. So this time equal to 0, and this here 5 seconds, and this here suppose 10 seconds. And this is given to you, this is 40, this is given kilogram meter per second, momentum in kilogram meter per second, and time is given in seconds. And now you are supposed to calculate different parameters. Okay, so what you are supposed to calculate is this A part. Calculate momentum P at t equal to 2 seconds, 5 seconds, 7 seconds. At these 3 different times you are supposed to calculate the momentum. B part, let's calculate B part. Calculate force F at t equal to 3 seconds and 8 seconds. At these 2 different times you are supposed to calculate the force. Okay, so let's do part A. So part A is like this. We have to calculate what? Momentum. So momentum at t equal to 2 seconds. At t equal to 2 seconds we will have to calculate the momentum at this time. Okay, so simply if this is 0, this is 5, 2 will be obviously somewhere in between the 0 and 5, isn't it? I will draw a perpendicular line, and the momentum here will be like this. So we have to calculate this P. अब ये ले लो theta, then calculate tan theta in the छोटा triangle and in the बड़ा triangle. So from there you can calculate what is the value of P. Okay, obvious. Now here what I will write down is this tan theta. In the smaller triangle it will be perpendicular P divided by base 2. In the larger triangle, in the bigger triangle, it's equal to 40 divided by 5. So P divided by 2 will be equal to 40 by 5, that is equal to 8, which implies that this P is equal to 16 kilogram meter per second. बस हो गया, ठीक है ना बेटा? So this is 16 kilogram meter per second. Then B part is that you will have to calculate the momentum at what time at t equal to, sorry, it's A part again. It's A part again. So here I will write down. So you have to calculate the momentum at t equal to 5 seconds. Okay. So t equal to 5 seconds. Simply momentum will be equal to 40. T equal to 5. Momentum is 40. So momentum is 40 kilogram meter per second. Directly you can calculate, isn't it? Then you will have to calculate at t equal to 7 seconds. So this is 5. So this somewhere here it will be 7. Then try perpendicular. This point P. We have to calculate the momentum. This P. Okay. Again, suppose that this angle is theta. Then again, what I will write is this: at t equal to 7 seconds, you will have to calculate now. Okay. So at t equal to 7 seconds, let us define tan theta. Tan theta will be perpendicular in the bada triangle. In the larger triangle, perpendicular is 40 divided by base. So in this triangle, this is 40. And this is base, this is 10 minus 5, that is 5, is equal to, in smaller triangle, this is here P, and this is 10 minus 7, that is equal to 3. So P divided by 3. 40 by 5 is 8. 8 multiplied by 3 is equal to P. So momentum P will be equal to 24 kilogram meter per second. Okay? Okay, so this is the way we calculate the momentum. Now next B part. Ab dhyan rakho beta, B part. B part is like this. We will have to calculate the force at the time 3 seconds and at the time 8 seconds. Now we know that the force from the Newton's second law of motion, force is equal to dP divided by dt, rate of change of momentum with respect to time, and that's also equal to tan theta. Tan theta implies slope of P versus T curve. So force, so first of all, at what time you have to calculate? At T equal to 3 seconds, we will have to calculate what's the force at this period time. So I will define force is equal to tan theta. And tan theta in this very triangle. Let's calculate in this triangle. It is simply perpendicular divided by base. So how much is perpendicular? 40. How much is base? 5. So it is equal to 8 Newton. Answer. ठीक है ना बेटा? And at what time you have to calculate next? At t equal to 8 seconds. T equal to 8 seconds. That means 8 seconds will be somewhere here. So you have to calculate slope of this curve. ठीक है ना बेटा? If you are supposed to calculate the force at 7 seconds, 6 seconds, 8 seconds, 9 seconds or 10 seconds, the answer will be exactly same. Because from this point to this point, momentum decreases at the constant rate. So the force from here to here will be a constant, but it will be negative. In this very case, from here to here, from O to A, force will be positive. It is positive because the slope is positive, or the momentum is increasing from point A to point B. The force is negative because the momentum is decreasing. So at t equal to 8 seconds, force F will be again equal to tan theta. That will be equal to minus 40, because here again perpendicular is 40 and base is 10 minus 5 is 5 divided by 5, so that's equal to minus 8 Newton. This plus 8 Newton implies it is an accelerating force. This minus 8 Newton, it implies it is a retarding force. Bas ho gaya. So we have done two examples on what? Momentum versus T curve is given to you, and you are supposed to calculate the instantaneous momentum and the instantaneous force. Okay. So again, pause the screen and write it down. Likho beta yahan tak. Okay, next example will be on what? If force versus T curve is given to us. So I'll rub this off now. So let's do example number 3rd. Let's do example number 3rd. So let's do example number 3rd. Ab dekho beta. Example number 3 is like this. That is force versus T curve is given to you. Force versus time curve is given to you. And a question is asked in AIPMT 2014 on this. Okay. So force Newton and time is given in seconds. Okay. Okay. Now suppose that the force versus time curve is given like this. It is like this. Again like this, okay? Trapezium. And the force here that's equal to 20 Newton, and time here is 0, and here time is given that's equal to 2 seconds. The time here that's equal to 4 seconds, and the time here that's equal to 6 seconds, okay? If for example you are supposed to calculate the instantaneous force, you can do that, because in the similar fashion as you have calculated the momentum, instantaneous momentum. But what we will calculate here is this calculate. So here I will write down calculate A part. अब ध्यान रखो बेटा, calculate A part. Calculate A part. A part is that you have to calculate the change in momentum. Calculate delta T or impulse between T equal to 0 seconds and T equal to 6 seconds. And part B is that calculate average force, F average between T equal to 0 seconds and T equal to 6 seconds. So you have to calculate the average force and the impulse or the change in momentum. ठीक है ना बेटा? Okay. Now which equation to use here? So here I will write down A part solution on this A part. So here I will write down solution. So A part is like this. Simply we have what? Delta T is equal to I impulse, that's equal to integration of F dt, and that's equal to area under F versus T curve. Then this time we have to calculate the area. Okay. So simply here I will write down impulse or delta T is equal to impulse, that's equal to area. It's simply equal to area under the curve. Area of trapezium. Area of trapezium. Which trapezium? This trapezium. O, A, B, C. Okay, so let's calculate the area of the trapezium OABC. Okay, from here we can calculate what that's equal to, in turn equal to momentum, or that's equal to impulse. Okay, so here I will write down delta T. अब देखो बेटा, delta T is equal to impulse, and that's in turn equal to this area of trapezium. Now you know how to calculate the area of trapezium. कैसे करते हैं? Area of trapezium is equal to 1 by 2 sum of parallel sides multiplied by the perpendicular distance between the parallel sides. So area of trapezium will be equal to this 1 by 2 sum of parallel sides. One parallel side is this, that is 6, plus another parallel side is this AB, that's equal to 4 minus 2 is 2. So this is 2 and this is 6. So 6 plus 2 multiplied by the perpendicular distance, that is this, which is equal to 20. So multiplied by 20. So this is equal to 6 plus 2 is 8 multiplied by 2 ones are 2, 2 tens are 20, 10. So this here 80 kilogram meter per second. तो ये आंसर है. Delta P is equal to I. So we are done with the A part. ठीक है ना बेटा? Okay. So next part is the D part. We have to calculate average force. Average force is simply like what? It's equal to delta T. Delta T was 4 गया. Delta P calculated 80. Divided by delta T is what? 6 minus 0 means equal to 6. 6 minus 0, that's equal to 80 divided by 6, or that's 40 divided by 3 Newton. So here is the answer. Or you can also write it is equal to 13.3 Newton. Answer. Easy problem. No rocket science in it. ठीक है ना बेटा? Okay, so simply what we have to calculate is the delta P or impulse. It will be equal to area. So area of the trapezium is in turn equal to 1 by 2 sum of parallel sides multiplied with the perpendicular distance. Okay, and then you have to calculate the average force, that is delta P by delta T. We have calculated delta P, then substitute the value of delta T and calculate what is the average force. Done? Okay. Okay, again pause the screen and write it down. Hello dear students. Okay, so we have some previous year questions which are asked in the NEET and AIMS. Okay, so first of all you pause the screen and write down all these questions. 3 questions are there. Question number 1 is asked in AIMS 2019, and question number 2 is asked in AIMS 2011, and question number 3 is asked in AIKMT 2009. Okay, so first of all you write down all these questions. Okay, you pause the screen and write down all these questions, then we'll solve them. Okay, so let's solve example number 1. So example number 1 is like this. I'll rub this off. So let's see what's example number 1. In example number 1, force is given as a function of time. There is a force which is exerted by a gun on the bullet and is given by this. Okay. Then the bullet emerges with a velocity of 400 meters per second. Then you will have to calculate the impulse, which is also change in momentum, exerted till the force on the bullet becomes equal to 0. Okay. Okay. अब ध्यान रखो यहाँ बेटा. So first of all, what we'll write down is this force. So force is given to me. So the solution is like this. Force is given to me. That's equal to 100 minus 0.5 into 10 to the power 5. Or I can write like this. It is equal to 5 into 10 to the power 4 T Newton. Isn't it? because 0.5 is 5 into 10 to the power minus 1, so 10 to the power minus 1 and 10 to the power 5 will be equal to 10 raised to the power 4. Okay. Okay. So next, what I will do is this: I will calculate. Then you will have to calculate the impulse exert till the force on the bullet becomes equal to 0. We'll substitute that the force is equal to 0. Suppose that force is equal to 0. This implies that this 100 minus 5 into 10 to the power 4 multiplied by t is equal to 0, which in turn implies that 100 is equal to 5 into 10 to the power 4 multiplied by t, isn't it? So this 10 to the power 2. So this will be here. I can write it like this. This here 10 multiplied by 10 to the power 1 multiplied by 10 to the power minus 4. This one divided by 5. What is equal to t? Okay. So this here 10 and 10 to the power 1. Then here it is 10 to the power minus 4 और यहाँ आ जाएगा 5. Okay. So 10 by 5 is equal to 2 multiplied by 10 to the power 1 minus 4, that is minus 3. So this is equal to t. Okay. So at this time the force will be equal to 0. Okay. Now how to calculate it? अब ऐसे कर लेते हैं बेटा.